Hello, everyone. Welcome to my retrospective stream about the 2-week NES Emulator Challenge. I'm basically going to talk about how the challenge went, where I got to, which you can see running over here, and a little bit about what I did well, what I did poorly, what I'd do differently next time, and what I'm planning to do next. So, thanks everyone for coming by, and let's get started talking about it. So obviously I did not complete the original challenge. The intention was to have an NES emulator that was capable of running Super Mario Bros. 3 flawlessly through the first level without sound in 2 weeks or less. What I achieved in 2 weeks or less is this, which I'm affectionately calling Haunted Donkey Kong. It obviously has some problems. But let's talk about kind of the process that I went through to try and achieve this thing that I set out to achieve. I'm just going to leave that running on the side here so that we can all watch it be horrifying. I started out, hi Velocity, hi Lila, hi the kitty cat. So I started out, basically, I knew that NES Test was a thing. So NES Test is a test ROM that comes from Kevtris of the Analog Mini fame, or Analog NT, I forget what it's called, Analog, anyway. And it is supposed to basically go through and test all of your CPU instructions and make sure that they're implemented correctly. As we will see later, it doesn't 100%, but basically this is where I started. I knew this existed. I figured, okay, I'll pass that first. Then I knew that Donkey Kong was a very simple game that didn't use any kind of scrolling or anything like that, a mapper that's too complicated. So then I was going to get that running and then move on to Super Mario Bros. 3. In order to get this to run, you basically have to be able to parse it. The file format is called INES. Pretty straightforward to do that, so that's where I started out. And my parsing code is right here. It's very easy. Just suck things in, read them into a file, or read them out from a file into this sort of header structure, and then the various ROMs and RAMs and whatnot. It's very easy. Just follow the instructions. So then I went on to the CPU, right? I have to implement something. My CPU implementation is pretty weird. Typically, the way that this would kind of work is that you would just have a main loop that runs through and fetches the instruction, executes the instruction, and that would basically be the end of it. But I know that for the NES, you need sub-instruction timing to be correct for certain opcodes. And the way that this works in the real NES is that there is a lookup table of that basically it's a ROM that matches against the instruction you're executing and the clock cycle you're on of that instruction in all of the rows of the ROM. And all the rows that match will output a signal, and that goes into a big mess of combinational logic, and that just tells the CPU what to do on every instruction. So we need that level of accuracy for some games. The most notorious one is Battletoads. And so what I ended up doing is a technique that I originally came up with for my N64 emulator project. But basically, I created a queue of micro operations. And then my main loop, all that the main loop does is basically just pop that queue and then execute it. Execute the function represented by that token. And Rust makes this really easy to do, which is nice. One of the things I like about Rust is it has support for these sorts of higher level abstractions. So I basically have a queue of function pointers, and I pop them. Some of them have additional information associated with them, and then I execute the function. And that worked really well. This is probably overkill for an NES emulator. There's sort of this is sort of in the middle of two approaches, right? You could have an extreme one where you actually implement that instruction ROM that I was talking about, or you could have a very simple approach which only does instruction level timing. And this is sort of a middle ground that I found, and I was happy. It worked really well. The main issue that I had with it is that there are a lot of places where it's like, I want to do exactly the same thing, except that I want to do it with the program counter or with the address bus. And I ended up duplicating a lot of those opcodes. So we have like fetch to and read to are basically the same operation, just using a different pointer into memory. And so if I'd been a little bit more clever with these opcodes, I could have shrank the number of them somewhat, but it's just not really worth it, honestly. I'm pretty happy with how this came out. Then to actually implement the instructions, I just have a constant, which indicates the opcode and the addressing mode and the encoding in hexadecimal. I should zoom this in, huh? Probably can't read any of this. So it's got the opcode in hex, and then we basically just make a huge array where you look up it's an array of arrays, and you look up the opcode in the first array, and it gives you an array of function pointers. You push them onto the queue in order, and that's your instruction. And this worked really well. It meant that when I was implementing a new address mode, I just had to kind of mix and match. So like load absolute versus load absolute x, the only difference is that you use the fetch and index instead of fetch for the high byte of the address. And that's the only change, right? I didn't have to rewrite all this extra stuff. So it worked out really well. It let the CPU implementation work pretty effectively. I would recommend something like this. There are a few changes that I would make. First of all, I used Rust's discriminated enums to pass in values and stuff. That's not worth it. I should have just used a struct, and you'll see in the PPU that I did do that later. And like I said, I could have shrank this set of operations if I'd been a little bit more clever and allowed things to kind of happen at the same time. Went to a little lower level of resolution, but overall, I'm pretty happy with the CPU implementation. So when you run NES Test has this nice property, just described in the documentation, that you just have to point at, you set your program counter to C000, and it'll just run. And it's supposed to write the results into the test into locations 2 and 3. But it turns out that's not actually sufficient. It won't actually detect all of the problems that NES Test can detect. So what you want to do is compare against this golden log. And the best thing to do is to just take this, delete the information you don't have, like PPU and psych probably, and then make your emulator output something that looks like this and compare the results. And when I finally did that, I uncovered like 6 CPU bugs, most of which were just dumb copy-paste errors, even though I had previously passed NES Test. So that's something to be aware of. The next bit is the PPU, and this is really where I made a couple of poor choices. So one thing I did well here is instead of doing using the discriminated enums to pass stuff, like I did in the CPU. So like there's no data associated with these variants, right? I just used a struct that contains the opcode and then the 2 arguments. And that turned out to be a lot nicer. You can see the run loop is a lot shorter as opposed to in the CPU. Like there's these 2 redundant match arms that don't actually do anything all that useful. So yeah, using structs instead of enums for that was a much better choice. So that's great. The thing that I did wrong is structuring this as a queue anyway. I was sort of high off of my success from the CPU implementation. I really liked the architecture there, and I was like, well, PPU, it's just a weird CPU. It'll be fine. It turns out it's not. So the thing with the PPU is, let me find this tab real quick. I still have all my reference documentation open, which is way too much. There we go, this thing. So if you look at this thing, you can see that what the PPU is going to do on any cycle is pretty much completely determined by the cycle horizontally, basically the horizontal cycle in the scan line, and then the scan line number. And this is what I should have done, right? You know whether or not to execute some action based on what cycle you're in and what scan line you're on. And I should have just implemented it like this, right? Just written a big function with a bunch of conditionals that took in 2 numbers and then did all of the things that were live on those numbers. And that would have been a much better design. Instead, what I did is I started with the queue executing all of this stuff, right? So this is the background processing, which deals with name tables and tile sets and blah, blah, blah. And so these are tiles, anything that's not moving, basically. And so I wrote the queue version of that, and it actually worked pretty well. There were a few places where I had to do things like delay through H blank, which is this region right here, or like turn it off for several lines, but still keep ticking the queue, which were a little bit iffy, but it worked okay. But where it really fell apart is sprites, because you're supposed to be doing other things simultaneously, and the only way that my queue-based architecture could really handle that, because they're not always the same thing, right? Like you might be doing secondary OAM clear at the same time as a nametable byte fetch, but then the last nametable byte fetch, that's not what you're doing for sprites. The only way I could come up with quickly and easily to do that was to basically run a second queue. But it turns out if you run a second queue and your two queues are not in sync, that's where this horrible weird scrolling behavior comes from, where things just start sliding away on the background. That's why that happens. It's because my sprite queue and my background queue aren't synchronized. And the sprite queue is what runs the NMIs, which tell the system when to render the frame buffer. So the reason that the sprites, although they look terrible because I didn't finish implementing them, stay in place and the background goes bananas and starts scrolling off the screen is because of that lack of synchronization between the two. The other thing that I did that was not a great idea, although it was more manageable, is that my background operations took a tile instead of a cycle. That turned out not to be as useful of an abstraction as I thought it would be, because I was like, okay, this is one tile, 8 cycles per tile. It's great, cool, no problem. Except that it's a little bit of a problem because you have all this stuff in the middle where there's no tile, and then like this is tile 0 of the next scan line, and it just didn't work very well as the abstraction. I made it work though. It wasn't too bad. Okay, so now we have to actually draw stuff, right? That's the next step. We're fetching, we're doing all the things, we've implemented all the timings. Great, but we still have to put data on the screen. So the way that I did that, and you can see it in this, is that I used what's called Dear ImGUI, which is an immediate mode GUI library. I don't super love it 100%, especially since it's like floating in this white void window here, but I just didn't take a lot of time to learn how that would be better. But I have a frame buffer that I render to in the PPU, and I just get it, and I call get frame buffer, then I crunch it up and stick it into an OpenGL texture, which is this Glium stuff, and then I dump it into an ImGUI image, and it renders to the screen. So this is literally just the pixels that I write into the frame buffer get rendered to the screen. The way that we choose how to, like, which pixel to write is all done in this function called drawEbits, and you can tell that I was getting a little bit, I don't know, loopy, unprofessional at this point. But basically, you have all these latches that get set during these processes, and then you use them to select the color of the pixel that you're going to draw. And that's kind of here. You find the address, you look up what color is at that address, and then because the PPU renders in NTSC format, it doesn't do RGB because it's expecting to be hooked up to a CRT TV. We have this lookup table that converts it into an RGBA palette. And the NES Test Wiki was really good for a lot of this stuff. Like, it describes what the palettes are, and gives you an example palette to copy, and so that was all great. Unfortunately, a lot of the other documentation is not very good for PPU stuff, especially if you're trying to be cycle accurate. So there's like all this stuff that is just deeply confusing. Like if we find attribute tables, I eventually figured out what they were trying to say here, but it's not a very clear explanation. And I don't know, I struggled a lot with the NES test documentation for the PPU. I would say that that is one of the biggest things that kept me from finishing on time. I think that's all of the major subsystems. The only other thing is the mapper, which I implemented as a trait in Rust, which is kind of similar to an interface if you're familiar with object-oriented languages. So I made a trait for the mapper, which is get byte CPU, get byte PPU, set byte PPU, and it would have a set byte CPU if NROM had RAM on it, but it doesn't. So, and then I just implemented it for this NROM type that I defined, which is for the NROM mapper. So I guess I should explain what a mapper is, if anybody doesn't know. Basically, a mapper is a hardware in the cartridge, the NES cartridge, that like translates memory writes and reads and moves them around to various chips that might be in the cartridge or on the console or whatever. So different games have different mappers, and the one that Donkey Kong uses is NROM. The one that Super Mario Bros. 3 uses is MMC3. What challenge? Yeah, so the challenge was to implement an NES emulator that would run SMB3, the first level of SMB3 correctly in 2 weeks or less. And I did not succeed. As you can see, this is where I ended up. I got to this haunted Donkey Kong game, and that's all. Let's see here. So that's basically the things I wanted to say about the process of writing it. Really, my big mistake was the PPU implementation. I really should have made it a lot simpler once it was clear that like what was happening was a function of just the cycle and the scan line. Let's see, is there anything else interesting? I guess the other thing is the NMI. So there's an NMI that fires sometimes on VBlank, and triggering it was pretty easy from the PPU side because I'd implemented everything at sub-cycle accuracy, or sub-instruction accuracy rather, cycle by cycle accuracy. But I'm not super in love with the abstraction that I use to actually trigger the interrupt in the CPU, because I basically returned if there was an NMI from the PPU, stored it in a variable of the CPU struct, and then when I was decoding instructions was like, oh, by the way, if there's an NMI, do this totally other thing. So I don't love how that worked out. There's probably a cleaner way to do that, and I know it would have probably had to get worse when I added the IRQ, the interrupt line for mapper MMC3. It has its own interrupt lines, and I would have had to hack them into this same mechanism somehow. It probably would have been fine, but just kind of ugly. Are you going to rewrite the PPU then? Yeah, so okay, let's talk about that. I really enjoyed doing this challenge. Even though I didn't, complete it, I don't see it as a failure. I learned a lot. I had a lot of fun. It was great. So I don't have any regrets on that score. But the NES is not really a console I'm super passionate about. So I kind of have two roads ahead of me that I could take. One is I could finish this project, and that would involve a fair amount of rewriting. I would rewrite the PPU. There are some things that I would want to change. I would want to have like real logging, some amount of debugging capability that doesn't involve commenting out print lines all the time. Just generally applying something that vaguely resembles software engineering to the problem. So I could do that, and I think it could be interesting to watch. It could have some like pedagogical value, but I'm just not really feeling it, honestly. I don't really need to have an NES emulator that works. That's just not something that's important to me. However, the N64 is a console that is very important to me, and I think that there's a lot of problematic. Well, I just am not in love with the state of the scene, right? Like the existing NES emulator, or the existing N64 emulators rather, they just don't do it for me. They don't, either they're inaccurate or they're too slow or both. Like, and this is not to disparage the good work of the people in that community, but I think that there's a lot of more room for innovation, right? In that space, I would rather work on an N64 emulator because I think I could actually improve the state of the art. So that's what I'm planning to do now. Is I'm going to work on an N64 emulator. I'm not going to stream every day. It's too much. This was a lot for this challenge even. But what I will commit to is I'm going to do at least 4 hours a weekend for the time being. N64 emulation is not a solved problem. Exactly, Nick. NES emulation is basically a solved problem. You can just throw more compute at it and write the simplest thing that could possibly work, and it will. N64 is not that way, at least not yet. And so I think not a solved problem is exactly right. So I'm going to stream at least 4 hours, at least one weekend day, every weekend for the foreseeable future until something changes. And then I'll maybe try to layer in some weekday commitments over the course of time. And we'll see how it goes. I've really been surprised both at how much I've enjoyed streaming and at the response to it. Like I can't believe that my average viewers is more than 15 after 2 weeks. And I know a lot of that is y'all folks from the emulation Discord, but still, it's pretty cool. It's a nice little dopamine hit, and I think that I am more likely to push through on these various projects if I'm streaming them. So yeah, I'm gonna do that. I'm gonna focus on the N64. I think what I want to do is start with an RDP renderer because I want to learn a little bit more about 3D rendering. I want to. My plan is basically to capture RDP commands from an existing N64 emulator and then learn how to render them, right? And then from there we'll move on to other components. I think I have some ideas for the CPU RSP interaction that could be interesting that I want to play around with. There's a lot there. So that's my plan for the near term is an RDP renderer. And yeah, that's the plan. Does anybody have any questions about the project? Is anyone, strongly object to the N64 as a platform? Have suggestions for things that would improve the viewing experience? I'm definitely going to go in and set up, what's it called, Nightbot or some sort of bot. I might get some moderators or something, just dub some of you folks as moderators. Am I planning to write the N64 emulator in Rust as well? Yes. Rust is my current language of choice for non-professional projects, and I don't really see that changing unless there's a pretty good reason to. There will be ancillary tools and stuff written in Python, etc. aweigel/magic on GitHub is your N64 emulator. Yes, it's not really an N64 emulator, and I might just kind of archive that as the past version and switch to a new branch for the new work, but we'll see. Also, github.com/aweigel/red is the code from this challenge. Red is Rapid Emulation Development, and it has all of the final code, all of the committee stuff, etc. Yeah, so Pixel, that's exactly what doesn't work right now and what I will be setting up before my next stream. N64 starting right now? No, probably not. I've had a long day. I helped my dad move. So probably not today. Maybe tomorrow, though, depending on how things go. I would really like to get started. I'm excited. So, just to be sure, you did see my other messages about N64 lacking in documentation? Yeah, I did. And also about Qt. Yeah, so getting a better kind of GUI and actually implementing some debuggers and tooling and whatnot is one of the things that I want to be able to do when I'm able to take my time. So I'm going to do that. In terms of lacking in the documentation, yeah, I mean, that is true. There's a lot of documentation out there, but it's not all very well organized or very well explained. Fortunately, I've spent some time doing pre-work on learning how the thing mostly works. Yeah, scattered. That's a good word. So maybe as part of the stream, one of the things I want to do for the challenge still is write a blog post that basically is this stream but in blog post form. And maybe as I go through the N64 emulator, I can like gather up some of that stuff and we can put it on emudev.org, or I can host it on my own website or whatever. Maybe we can improve that situation a little bit, but yeah, for sure. And then I also, one of the things that I really want to do for the N64 emulator is integrated hardware testing. So I have purchased a 64 drive. Doesn't seem like that's going to arrive anytime soon. So I'm going to buy an EverDrive version 3 and hook it up to basically run side-by-side comparison tests against my emulator. I'm not totally sure how that's going to work, but that's the plan, and I have some ideas for like how I might make it function. Did you watch Ferris's N64 Emudev streams? No, I know they exist. I've heard good things. I haven't watched any of them. I probably will watch some of them. I'm waiting for a job to buy one as well. I'd be your coding buddy, but C++. I mean, maybe something that will need to be written is like tools to control the EverDrive, and maybe that could be in C++. I mean, if you're interested, I'm sure there are things that we could do. Serotonic, yes, just tuned in. You're planning a 64 emulator yet next. Yes, that is the idea. We talked about it a little bit, but I'm just not that psyched about the NES, and the NES emulator is kind of a solved problem where I don't think the N64 is. So that's what I'm going to work on next. I'm going to stream 4 hours at least every weekend. That's the commitment that I'm making. I might stream more, but I will stream at least that much, and we'll see how things go over time. Pixel, is that Ferris's stuff that you just linked in chat? Because this is a good reminder that my my YouTube channel is going to have all of these streams uploaded. I'm going to go through and give them better descriptions. I kind of fell behind, but the first 6 or 7 are up right now, and I'm going to get them all up and in a playlist and whatever. So if you want to catch some of the things that you missed and you're worried about the Twitch videos melting, you can find them at that link that Diana just posted. And again, I'll have a bot to do that later. You've inspired me to dig into emulation a little bit in Rust. That's great, Serotonic. I'm glad to hear that. That was one of the things I wanted to do, is kind of like show people that it can be done, right? Like something that I don't think I emphasized enough, because I didn't want it to sound like an excuse, is that this is my first emulator. I've never written an emulator before. I got it to this point in 2 weeks. That's pretty good. And if you are willing to give yourself a little bit more time and are willing to, talk to people, get help, you can do this. You can do way better than I can, certainly. So I wanted to show people that it's not as hard as it feels to make something like this. If you link your accounts on Discord, people can find them on your profile. Probably a good idea. Yeah, the Discord link is another thing that really I should have on a bot. Oh, you just joined today. Awesome. Yeah, so that's the Emudev Discord, the our Emudev Discord. So let me just pull up the link and I'll drop it in chat, unless someone else already has it. Chat. Yeah, so these are all the logistical things that I didn't know how to do because I had barely streamed before, and now I'm going to spend time setting up, right? Also, I am a Twitch affiliate, which is really cool. I was absolutely not expecting that when I got started. I thought that the requirements were more strenuous. So if you wanted to subscribe or, drop bits or whatever, I would appreciate that, but it's totally not required. Like, I have a job, don't worry about it. But I just think that is cool. Been digging into the Z80 CPU. Not sure if that's a good beginner project or not, though. Was hoping to poke at Game Gear. I mean, whatever you're interested in is a good beginner project, is always my take. That people will say, oh, start with chip 8, start with, byte pusher, whatever. Just start with what you're going to finish, right? Like this emulator thing, this NES thing, rather. If I didn't have this challenge, I wouldn't have done it because it's not what I'm interested in. So I think that's basically everything that I wanted to say. If there's any other questions or things that you want to suggest, whatever. So github.com/aweigel/red is the source code. Aweigel on YouTube. I dropped the Discord link. Come join us. Other than that, I mean, that's pretty much what I wanted to cover today. I still feel pretty good about this, even though, I didn't get where I obviously wanted to be. But I hope you're using streamer mode on Discord. It says that every time I go live. It's like, hey, buddy, you're in streamer mode. Stay safe, which I don't know what that means. So, yes. You can tell how prepared I was. Mutes notifications. Okay, I don't let it notify me things anyway, so. Yeah, well, thanks everyone. I appreciate you stopping by. I know this was a very short stream, probably like, 20 minutes? 30 minutes. But I just wanted to kind of update everybody on the challenge, let everybody know what I'm planning to do next, etc. Let Pixel nag me about not having a bot. But yeah, absolutely. Thanks a lot, everyone, for stopping by. Please continue to, check it out. Like I said, I'll be streaming at least 4 hours. I'm going to try to do something tomorrow. I have a lot to do this week, and this week is not over yet for me, sadly. But I'm still going to try to do at least a couple hours tomorrow. But I'll definitely do 4 hours maybe next Saturday or Sunday. Neat. Looking forward to it. It's been fun watching over the last little bit. Thanks for sharing the project. I look forward to the next thing. Great. Thank you both so much. I really appreciate it. Everybody have a good night, and I'll see you hopefully tomorrow.